Hello students, good evening. Today we are going to discuss L'Hospital rule. So students, why L'Hospital rule? Okay, so L'Hospital rule is used to evaluate the limits which will take indeterminate forms. For example, so whenever we are going to evaluate the limits, so first you have to know the indeterminate forms. What are the indeterminate forms? Okay, so indeterminate forms you will get when you are going to evaluate the limits. So indeterminate forms are first you must remember 0 by 0, infinity by infinity. These are coming under one group. Okay, so next infinity minus infinity and 0 into infinity. So these are coming under second type 2. Again there is one more, 1 raised to infinity, 0 raised to 0, infinity raised to 0. These are coming under type 3. So these are indeterminate forms. Now I will tell you when you will get these type of forms. I will take simple example. Okay, let's observe this, evaluate. Okay, and observe what is the value of x tends to 2. Substitute x value is 2 and observe what will happen. 2 cube is 8 minus 3 2s are 6 minus 2 divided by 2 square, 4 2s are 8 minus 5 2s are 10 plus 2. Look at here student, 8 minus 6 minus 2 is 0. So 8 plus 2, 10 minus 10 is 0. So 0 by 0 is indeterminate forms. Okay. As I already mentioned that why L'Hospital rule? L'Hospital rule is used to evaluate the limits which will take indeterminate forms. Other than L'Hospital rule, we also have a methods. I think we have already studied in plus 10 plus 1 level, PUC level, or 10 plus 2 levels. There you have some standard limits and evaluation of a limits by substitution method, by rationalization method, by factorization method, and by taking common. So there are 4 types of methods in PUC level, but in graduation level we are going to discuss by the help of L'Hospital rule. So what is L'Hospital rule? First I will go to explain the method. So we have a fraction, rational fraction, f of x divided by g of x. F of x and g of x both are polynomial of some degree. Okay, so limit as some x tends to some a. Okay, so first to evaluate these kind of rational fractions, f of x by g of x as limit x tends to a. Okay, first you can call it as some k, start with some k. Okay, say k. Okay, then you must check whether it will take indeterminate forms or not. Check x is equal to, check by substitution of x equal to a. Okay, look at here, by substitution of a, what you will get student here? So this is f of a divided by g of a. And remember that if g of a is not equal to 0, if g of a is not equal to 0. Okay, so we are not going to discuss about this g of a not equal to 0. I told you already that first we are going to check whether it will take indeterminate form or not. So by substitution of x equal to a, both f of a is equal to 0, again g of a is also equal to 0. That is 0 by 0 form, or it may take infinity, both take infinity and infinity. If it takes 0 by 0 form, we are going to apply L'Hospital rule. So what is L'Hospital rule? L'Hospital rule is you need to differentiate both numerator and denominator separately. Okay, differentiate both numerator and denominator separately and substitute the limits. Okay, and remember that denominator is not equal to 0. If denominator is again equal to 0, once again we are going to repeat the procedure. What is the repeated procedure means? We differentiate both numerator and denominator separately and we will substitute the limits till we get denominator is not equal to 0. Until then we are going to repeat the procedure. Okay, look at first. Left side is k as well. Okay, so you write as it is the limit. You differentiate both f dash of x and g dash of x and substitute x value and observe that what? Substitute x equal to a and observe that g dash of a, substitution of x equal to a, g dash of a is not equal to 0. So if g denominator is not equal to 0, stop the procedure. If again g dash of a is equal to 0, repeat the procedure. Repeat the procedure means differentiate again. Repeat the procedure means what? I am writing here. Differentiate both numerator and denominator with respect to x and substitute the limit. That is, I am writing here, you write limit as it is, limit as x tends to a, differentiate f dash, you will get f double dash of x divided by g double dash of x. Remember that by substitution of limit, g double dash of a is not equal to 0. If d double dash of a is not equal to 0 means stop the procedure. Okay. So whatever the value you will get by substitution of x equal to a, that is the limiting value. Further, if denominator is again equal to 0, repeat the procedure. So this is the L'Hospital rule. Students, we are going to discuss one simple example by the help of L'Hospital rule that I have already mentioned. Okay, let's discuss that. The procedure is very simple. People are already aware. Okay. Let us discuss this example. As you know already. Okay, evaluate the limit. Start with let k is equal to limit as x tends to 2 x cube minus 3x minus 2 divided by 2x square minus 5x plus 2. As you know that we have already checked numerator by substitution of x equal to 0, you will get 0 by 0 and you write which is indeterminate form. So what you need to do, student? We differentiate. We apply L'Hospital rule. Okay. Apply L'Hospital rule. What is L'Hospital rule? We are not applying left side, applying only right side. Okay. Differentiate d by dx of x cube minus 3x minus 2 divided by d by dx of 2x square minus 5x plus 2. Okay. And observe what we get. Differentiate it. Limit as x tends to 2. X cube is 3x square minus 3 minus 2 is 0 divided by 2x square in the denominator. 2x square is 4x minus 5. And observe, you have differentiated and substitute the limiting value. Substitute x equal to 2 and observe 4 2s are 8. 8 minus 5. How much? 8 minus 5. 8 minus 5 is 3. Denominator is not equal to 0. Stop the procedure. So substitute the limiting value. 3 into x is 2 square minus 3 divided by 4 into 2 minus 5. 2 2s are 4. 4 3s are 12. 12 minus 3 is 9 divided by 8. 8 minus 5. 3 which is 3. So which is the required answer. In the next video we discuss some more examples based on L-Hospital rule. Thank you.